Welcome to solverfy.
So we want to find the time it takes for the balloon to reach a height of 12 meters. So we can first apply Newton's second law. The buoyancy force must be equal to the mass of the balloon times g plus the mass of the helium that is inside that balloon times g plus the drag force. And so we can then substitute and say that 4/3 pi times r cubed times the density of air times g will be equal to the mass of the balloon times g plus 4/3 pi r cubed times the density of helium times g. We're going to model the balloon as a perfect sphere, plus 1/2 times essentially the coefficient of drag times the density of air times pi r squared times the terminal velocity squared. And so we can then solve for the terminal velocity. This would be equaling the square root of 2 times 4/3 pi multiplied by r cubed times the density of air minus the density of helium, quantity minus g, close parentheses, times g. And so this would be divided by c sub d, the coefficient of drag, times the density of air times pi r squared. And so we can then say that here, this is equaling a height divided by a distance from the definition of what velocity is. And so the time would be equaling the height multiplied by the square root. And for the denominator, we have 2 times g times 4/3 pi multiplied by r cubed times the difference in the density of air and the density of helium minus m. And so for the numerator, we have the coefficient of drag times the density of air times pi r squared. And so now we can say that solving for t is going to be equal to 12 meters multiplied by the square root. My apologies. And for the denominator first, we have 2 times 9.80 meters per second squared multiplied by 4 pi over 3 times 0.15 meters quantity cubed. This would be multiplied by 1.29 minus the density of helium, 0.179 units kilograms per cubic meters, minus the mass, 0.0028 kilograms. So that'd be the mass of the balloon. And then for the numerator, we have the coefficient of drag, 0.47, multiplied by the density of air, 1.29 kilograms per cubic meter, and then multiplied by pi times r squared, 0.15 meters quantity squared. And so we find that then the time taken for the balloon to reach 12 meters is going to be approximately 4.9 seconds. This would be our final answer. That is the end of the solution. Thank you.